Okay, so this is just going to be my video for chapter 2, which is going to be normal distribution, and just like chapter 1, I'm just going to be going over some definitions that I really want to remember for the AP test, and then going over a few examples that correlate with those key terms. So let's get into it. So the first one is a density curve, which is a curve that describes the shape of describes the shape of a distribution, and the total area is 1. So for example, this would be 0 and this would be 1. And just like the curves we talked about in the other chapter, it's kind of hard for me to remember left skewed versus right skewed because it's kind of like counterintuitive. So I try to remember the opposite, like if the peak's at the right, then it's left skewed and vice versa. And the median tends to be in the middle too. And so the empirical rule is a general rule that describes the areas and relative frequencies in a normal distribution. So for example, this is a density curve, but this is a normal density curve. And it also happens to be one that follows the empirical rule, which is, so this is 68 because both of these are 34, and it gives percentages for each of the standard deviations that go out. Just kind of like as a general rule of thumb, it can be really helpful. And I know a lot of the problems ask you to specifically use the empirical rule. The next is the inflection point, which is where the curvature appears to change direction. So like for example on this one it'd be here and here. It shows that again here. Okay, so normal distribution is a symmetric distribution which the mean, median, and mode are all the same value, which would be right here. And it can be modeled by a bell-shaped density curve. That's how I like to remember it. And it's pretty simple because if you're on a histogram, it also kind of looks the same, just more blocky. And empirical rules are also normal distributions. Like this is a normal distribution and it falls under the empirical rule. So a percentile is a number that indicates the percent of observations in distributions that fall at or below that particular value. And so like an example of this, which I've been learning, is like falling into certain percentiles with like ACT tests and SAT tests. And so that's how I've been like applying it to my real life. And then a z-score, it shows the number of standard deviations you are from the mean. So the formula for it is z equals whatever the number is minus the mean divided by the standard deviation, and that gives you the z-score. And then you can also use algebra. So like say you had the z-score and you wanted to find out the mean, or you wanted to find out the x, the standard deviation, you can just plug in and solve for those values, which is something I struggled with at the beginning of the unit, but I think I picked it up by the end. Okay, so now I'm going to be showing some just examples. Okay, so these are some things I struggled with, but I think I've gotten hang of them now. So distribution of heights of young women ages 8 to 24, that would be normal because there tends to be like an average height, and then people that fall above or below that usually go like a normal curve. However, a distribution of the heights of all students, men and women, that would be bimodal, which is a term I learned the first unit, because men and women have different like averages and stuff, so it wouldn't just be one normal curve. And the average length of human pregnancies would also be a normal curve, just because it usually follows a cycle, and like if it doesn't, like 9 months, that's not average kind of thing. Okay, let's see. Okay, and so then what is another name for the empirical rule? This name I decided to memorize just because it would actually give me the formula I needed, and it's called the 68, 95, 99.7 rule, because those are the three standard deviations. So if it's like within one standard deviation of the mean, above or below, it's 68%, 2 is 95%, 3 is 99.7%. And it's helpful just because it can help give you a rough estimate, especially if you are dealing with normal distributions. So, yeah. And then lastly, use your graphing calculator to find the area understandable normal curve. Z equals negative 2.34 and negative 5. So I know you go to you go to normal CDF. Let's see if I can remember how to get there. Yep, normal CDF. And then you plug in, what are the two numbers? Negative 2.34 and 0.5. And then you do the mean and standard deviation, but if there's not one, it's just 0 and 1. So that would make it 2.989. So yeah, those are just what I wanted to review this unit after watching the video that one of the teachers made, just the things that stuck out to me, the things I want to remember. So yeah.